Okay. So today we're going to be talking about malaria. And one of my main aims today is to address you the question of, are we doing enough to eradicate this disease of malaria? Like what we're doing right now, is that enough? So, a little background info on what malaria actually is and how it's transmitted. So malaria has been around for thousands of years. So you may ask yourself, what is malaria? Malaria is just a plain old disease. It's just a disease that's like any other disease, it gets transmitted. But the thing is, this disease eats our red blood cells. And our red blood cells provide us with oxygen. And basically a little overview of how it's transmitted throughout our ecosystem, society, community. Basically, a mosquito has to bite us, but the mosquito, it can't just be any mosquito. It has to be a mosquito that actually has the parasite on it, the parasite malaria. And once it bites us, we have the disease, and it matures in our liver, and then it gets widespread across our body, and it eats our way at our red blood cells. And what happens after that is another mosquito comes along that does not have malaria, it bites us, and then it has malaria. So it's like this ongoing cycle that keeps on going around in our ecosystem, and that's how it basically gets transmitted through our society. And that's why it's really a big problem in the world today. And as you can see on the map, which is not up here because I don't actually have a slideshow to show you right now. Well, there's a map and it shows the regions, and as I recall, the green area is basically free of malaria, the red area is contained malaria, and the yellow area is like mild, where the mild dense regions of malaria are. And as you can see, America is like completely green in that map, which means obviously it's because we basically have the accessibility, and we're privileged to have accessibility to these medications that are provided to us, vaccines, antibiotics, and such. But these countries, third world countries like Africa and Asia, the countries in these two continents, there are areas where people are destitute. They're not even able to sustain themselves. People are dying from this disease. And I will repeat this constantly throughout my speech, is are we doing, is it morally correct to do nothing while we're sitting in our houses, living a normal life, not being harmed by this disease, while people are dying and suffering from this disease? And basically, that's basically how malaria looks like. It's, so as you can see from the map, it is epidemic in the world today. And a little history on what malaria actually, how it all started. So malaria's been, as I said before, it's been around for thousands of years. And who actually discovered what malaria is like and how it's transmitted is Charles Laveran. He was an army surgeon in the French military. And basically what he did, he saw these people that were getting sickened and they had deadly symptoms. And he took their blood samples. And what he did was, as he looked through it under a microscope, obviously, he saw that there was a parasite that was in it. And logically, you can come to the conclusion that this parasite is what's causing all these symptoms. And he was correct, because eventually people found out that through this parasite, they found out how this disease was transmitted as well. They basically found out that mosquitoes transmit this disease. And as it was discovered, people began to look for methods of treatment and methods of eradicating this disease. An example is the U.S. Public Service. They lasted from about like 1947 to 1951, and what they did was they set up military bases around the U.S. and they didn't just set them up randomly. They set them up logically in places that needed the most help with this disease, that had dense populations of people with the transmitted disease. And they eventually got eradicated throughout the U.S. and they fell apart. It didn't work. And one of today's major organization, like there are many, but one of the major ones is that I'm going to focus on today is the Bill Gates and Melinda Foundation. They invested $2 billion. That's like a lot of money. That's like no average human being will make that much money in their lifetime. And what they do is they invest this money in research of preventing this disease, thinking providing research for vaccines, ways of preventing it, for example DDT, but less harmful alternatives. And they do collaborate with the government, so they do know which areas they pinpoint at which areas are need more help than others, which is also good. And that's basically what they do. And we're about, well, I don't have the PowerPoint, but we're about to watch a movie, clip of Bill Gates talking about the disease of malaria. And what he talks about is basically how his organization is cutting down death rates, and he gives us a perspective on how to approach this disease, like how to eradicate it. And yeah, that's pretty much what he does in the video. And I can't really show it because I don't have the PowerPoint. And moving on. So now, what are we doing today to prevent this disease? Yeah, obviously we have medications to prevent this disease, but then what else? Third world countries, we can't really provide them with medication because it's going to cost a lot of money. So we basically think of ways to prevent it in the first place, like DDT and nets, like bed nets. Basically, it's like what's another word I forgot? Yeah, nets. So basically, people sleep. They put net at night because mosquitoes are most active at night. That's when they basically hunt and not hunt. That's when they get their food source. That's when they're most active basically. And people are sleeping, and people would bite them. They wouldn't even know that a mosquito bit them, and they would contract this disease and die. Most likely they would die unless they have this miraculous immune system. And as they did this, the problem is that the mosquitoes adapted. They went through this a really short Charles Darwin evolution type of survival of the fittest thing. And what they did is they started hunting during the daytime. They were more active, and they would bite the humans, and then they would continue this whole cycle. And that just shows us how, as we try to counterattack it, it's going to adjust to what our counterattacks. So it just shows how this disease is constantly on the move, and it's constantly changing, altering, and mutating. And another example is, I don't know, it's not on the slideshow, but then there's this pill called artemisinin. Well, it's not a pill, it's this, well, yeah, it's basically a pill. It's this vitamin type of thing. And it basically it cures the disease. But the thing is, recently, they've, as I recall, it's not on the slideshow, but then, it's just interesting to know. In Spain, they found mosquitoes that have mutated to, the mosquitoes that have the disease that have mutated to counterattack, bypass this treatment option. And obviously that's bad, because now they're basically saying stop using this treatment method, because sooner or later we won't even be able to use it, because it's like antibiotics. It's if you keep on taking antibiotics, you can't use it later on, because the bacteria adjusts to it, so they are able to create antibodies that are able to counterattack the antibiotic that we're taking. So that's pretty much just a little interesting info, even though it's not on the slideshow. And continuing, one of the main methods that was used and still is used, not everywhere but a little less, but is still used, is DDT. And what DDT does, it creates this cycle. So basically, let's start with this. So you pollute the society ecosystem with DDT. Yes, the mosquitoes die, but then other animals eat the mosquitoes. And what happens is, it's an ongoing chain. They eat each other, and then there's the top of the food chain. We eat the top of the food chain, and then we get affected through it. And it's this ongoing cycle. And I have a slide, but then I don't have the slideshow. I don't have the slideshow up here. So to continue, basically it's really interesting, because once you release this DDT into an ecosystem, what it does is it increases in concentrations. So you can start with a really tiny concentration of DDT, and as you increase up the food chain, just miraculously just increases by large summation amounts, and that's pretty bad because we eat these animals. We fish for fish. We obviously hunt for animals. We eat them. It's part of our diet. We can't really do anything about it, and accordingly we're infected, and we're eating these high concentrations of DDT, which is quite bad. And as you noticed, they're like, it's basically like the problem of like we should watch out for the concentration of mercury in fish because we're polluting the ocean. Same thing with DDT, except for it's a little more harsh because mercury is not really highly concentrated in fish today, but then DDT is, because it's just one of those chemicals that quickly adapts and moves across the food chain quickly, and it does reproduce quickly, like chemical wise, and basically after that what happens is the animals mutate and they aren't able to sustain a natural like lifestyle that they were able to. They basically aren't able to adjust to their environment anymore. They mutate. They have mutations such as, for example, the bald eagle is one of our national symbols, and it's been endangered like 5 years ago. And this DDT, what it's been doing, it's been thinning the eggshell of the bald eagle egg, and it's so soft and permeable. It's easy to puncture. So obviously the birds die before they even hatch, and obviously that's one of the contributions to why it was endangered before. Now it's not, but then can you believe it? We let our own national symbol be endangered. And that's just how DDT just moves like throughout the ecosystem. And as you can see from the diagram, which isn't up here, but it's in the PowerPoint. If you look at it, there is increases in concentrations, drastic amounts. Like, wait, let me look at it. So like, it starts with like what, 0.044. I don't know what this unit is, but I don't know. But then it moves to like 13.8. What? That's like a huge difference in concentration. Like, and we're consuming these animals that have like 13.8 whatever ppm is, and it's horrible. It's we're just getting infected with this drug like chemical, and it creates like it creates a hazardous like ecosystem. And what I would like to ask you is, like, although DDT is quite effective in stopping the disease because it does kill off mosquitoes, like, are the negatives outweigh, if the positives outweigh the negatives, is it still moral to keep on using DDT? Like, are we doing the right thing by using DDT for the prevention of malaria? That's just something I would like to address. And that's one of my aims also. Are we doing enough to prevent this disease? And whatever we're doing, are we doing the right thing? And yeah, that's basically what I want you to ask yourself every day. Like, that's basically what I want you to ask yourself every day. And thank you. That's basically a summation of what malaria is, and that's what I wanted to address you today. Thank you.